Hey students, so for the homework video tonight, we're going to be doing two things. First, we're going to learn one new concept. You may have seen it before, but it might be new to some of you. And then we're going to do a little bit of review from today in class, or yesterday, whenever you're watching this. So another way that we use exponents is in prime factorization. So that is expressing something as a product of its prime numbers. So make sure you take note of that. If you guys remember what prime numbers are, you might remember that some of the prime numbers are 2, 3, 5, 7, 11, 13, 17, and so on. And the definition of a prime number is it's any number that can be divided by exactly two numbers, itself and 1. Okay, so if you see 2, it's divisible by exactly two numbers, 2 and 1. Same with 3, 5, 7, 11, 13. So make sure you have this definition somewhere in your notes as well. So what we're going to look at, we're going to try to get this as a product of its prime numbers. We're going to look at number 36. So we're going to think about the factors of 36. So factors are what times what will give me 36. And I can think right away. I think of 6 times 6. So we're going to split this up into its factors, and we're going to go all the way down until we get to the prime factors. And 6 and 6 are not prime numbers, so I'm going to continue. And 6, and I can do 2 times 3. And the same thing here, 2 times 3. And now I notice that 2 is a prime number, 3 is a prime number, 2 is a prime number, and 3 is a prime number. So now we stop. So once you get to its primes, you stop. And then you write this using exponents. Okay, so I've got a 2. I've got two 2's. So how do I write that using exponents? 2 squared. And that's multiplied by 2 3's, which is 3 squared. So this is the number 36, has the same value as 36, but it's just written as a product just means multiplication, of prime factors. And if you were to multiply this out, you would see 2 squared is 4, and 3 squared is 9, and 4 times 9 is 36. So these have the same value. This is 36, and this is worth 36. It's just written in a different way. Let's try another. If you want to write 75 as a product of its prime factors, we can do this a few different ways. I first think of 3 times 25. Oh, and I see that this is a prime number, 3, so I'm going to stop with this branch. 25 is 5 times 5. Oh, and 5 and 5 are both prime factors, so I'm going to stop. And then how many 3's do we have? We've got 1. And we've got 2 5's. So this is the number 75, written as a product of prime factors. That's just another way that we use exponents. Okay, so let's take now a look at a review of what we learned in class today. I'm just going to go through each of the different slides, and there's a video, there will be videos linked, if I can get it to work, to the different topics. So if you don't understand them, you can click the video and use that to help you. So index form, another way we say index form is with exponents. Right? Exponents and indices are the same thing. So for these types of examples, I just look at how many 3's do I have. I've got 3 times 3 times 3 times 3. 3 times itself 4 times. M cubed, 6 squared. Now we're going to do the opposite. 2 to the 5th, how do we write that in expanded form? Well, that's just 5 2's. And sometimes expanded form can be really helpful. Like in this question, I would probably use expanded form to solve it. So this is 7 3's, so I would write out 7 3's, and then I would think to myself, 7 times 7 is 49, and I've got to multiply 49 by 7 again. Okay, so if I were to solve that, I could write that in expanded form. And a to the power of 5 would, of course, just be 5 a's being multiplied together. We're going to use expanded form next class, so make sure you understand what that means. It just means to expand it. Okay, so find the basic numeral. It's a fancy term for just find the number 4, okay, for these problems. So what we did in class today, we looked at problems like this, so 4 times 4 times 4. And it is helpful to write in the expanded form sometimes, so 16 times 4, and then 16 times 4 to actually completely solve it out is 64. So that would be the basic numeral for answer for number A, sorry. And now this one, we're going to get a little bit more into this with the negatives, but this means the number -4 times itself. So it's -4 times -4. And we know a negative times a negative gives us a positive. So the answer for C would be 16. So make sure that you're using the order of operations here, and you're thinking about whether it's in parentheses or not, okay? So for this example, again, this is the same as last example. It's -4 times itself, so that will give us a positive 16. And then, this is where it gets a little bit tricky. Because exponents comes before multiplication, we have to first think about 4 squared, and then there's a negative in the front. And same here, we have to think about 5 cubed, which is 125, and then there's a negative in the front. And then this one is -5 times -5. You just see it's just -5 3 times. So -5 times -5 will give me positive 25. But then I've got to multiply that by -5 again. So that will be a negative 125. So something I hope you noticed in class had to do with these two problems. Something I hope you noticed is that when you had a negative number and it was multiplied by an even, or it was raised to the exponent to an even exponent, it comes out positive. And when you have a negative number raised to an odd exponent, it will come out as a negative answer. So that's a pattern that happens in math. Oops, the calendar's coming up. That's a pattern that happens with us in math, and it's pretty interesting. Okay, so make sure that you realize that these fractions are just the fraction, right? It's just 1/2 times itself 3 times. And it would just be 5/8 times 5/8 times 5/8 times 5/8, 4 times. And then this one was a little bit different because this one was 3 cubed and then divided by 5. So remember how exponents comes first in our order of operations? 3 cubed, which would be 27, and then it's divided by 5. So this one was a little bit different. I hope you also saw the pattern here when we're looking at 1/2. We're looking at a fractional exponent. So you have to think about 81, what times what gave us 81, and that's 9 times 9. So 1/2 of that would just be 9. And I hope you realize how that's related to the square root of 81. And that in fact means that they were the same. So actually, 81 to the power of 1/2 actually just is the same thing as the square root of 81. It's just a different way to write it. So think about what 36 to the power of 1/2 would be. Remember, it's just the same as the square root of 36. And for some scientific notation, so we've got 8.62 times 10 to the 7th, and we need to write that in standard form. That just means write it as a number. And what we'll do is we've got to take this decimal and we've got to multiply it by 10 to the power of 7. And what that means is we're going to move the decimal over 7 times to the right to make the number bigger. So if I had 8.62, I would move the decimal over 7 times. 1, 2, 6, 7, and this will be my new answer. So this would be the standard form of the number. Right? And you can do the same thing if you need to figure out what the scientific notation is. You can start here and count backwards because our decimal is here. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we remember, scientific notation always has one place value and then the decimal, and then any of those other important numbers that were not 0 after it, multiplied by 10 to whatever power, however many I had to go over. And that was again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's just a little practice with scientific notation. And I hope you guys are understanding this sort of stuff. Make sure you ask me if you have any questions about how to write in scientific notation.